Hello, Professor Sajadi. This is Felipe Zuniga from the Mortgage Calculator team, and this is the feature video for user story number 2827, the data pie chart. So, the main motivation behind this user story was to allow the user to view different fees, interest, taxes, and other useful pricing information as a fraction of the total monthly payment. We would also like for the user to be able to differentiate between these kinds of fees and see the difference in cost and basically play around with the calculator and use the data pie chart to see what's going to cost him or her the most, or what's bringing up the monthly price the most, and allow them to make a more informed decision when purchasing a property. So the acceptance criteria is as follows. Pricing information must be displayed in a pie chart. Pie chart has to use different colors to differentiate between different fees, taxes, and principals, and interest. Pie chart must also include a legend so that the user can understand the information being presented to them. And the pie chart must also display the numerical quantity in dollars for each fee and present the total payment per month. So without further ado, here's the data pie chart. So here we have our pie chart and our legend. So each of the mortgage pricing elements are color coded. We have home insurance in dark blue, property tax in light blue, and our primary principal in orange. We don't have any PMI right now because our calculations didn't calculate any PMI, and our monthly payment. So as you can see, the principal or primary is basically most of the cost right now. And one of the cool things with this data pie chart is that it clearly shows you, along with the legend, what you're going to be paying for the most. So in this case, for this home price with this down payment and this loan program, you're going to be paying basically almost all of your monthly payments going to be your primary principal. So before I jump into technical details, development, and testing, let me demonstrate how this pie chart works. So this pie chart works off data from the mortgage calculator tool. So any change I make to the mortgage calculator tool is going to make a change in the pie chart. Change the down payment. Now basically all we're paying is our primary principal. Change the interest. Change the property taxes. Give it a large property tax. Now all we're paying for is our property tax. Change our insurance. And you see our insurance increase. So basically this tool allows the user, along with the bar chart, to see exactly the total price that you'd be paying per month for a specific mortgage based on the variables that are introduced through the mortgage calculator tool. And it's very visual because it'll tell the user exactly what's the most you're going to be paying for. So in this case, the user's going to be paying for the most is the home insurance. Very clear that it's very expensive. And then the primary principal along with PMI and property tax. So that's a quick demonstration of the pie chart. Let's jump into the code. So to the left, I have the pie chart custom directive. This is basically what performs the calculations to calculate insurance, tax, principal, and PMI, and what actually displays the pie chart and calls a D3 object. Just like the data bar chart, this data pie chart depends on the D3 service, which loads the D3 library. And a quick overview of how it works is it has an isolated scope. So basically, whoever wants to use this pie chart passes in the data. So this scope.formData.hinsurance.ptax right here as an attribute. It passes it as an attribute to the pie chart. These are multiple pie charts in the same page. So it's proof that the pie chart is reusable. And you also pass it the attributes to watch for. Now, what does this watch mean? Basically, the pie chart is going to change on these specific, whenever these specific variables are changed. So, home price, insurance, payment, home insurance, and this is insurance rate, property tax, and the years for the selected loan. Now, if we look at the inputs here, these are all the models for our inputs. Basically, it has a view controller, model view controller framework, just like Angular. You pass it the attributes you want to change on. So, and the directive basically watches these attributes. Whenever there's a change in one of these attributes, the directive is going to recalculate the pie data, and then it's going to redraw the pie chart itself. And these are all specified through attributes and obviously form data. So before I actually had the pie chart have the same scope as the parent controller, and the pie chart and the parent controller were in sync. Now this might seem like it's useful for our pie chart, but it won't allow the pie chart to be reusable. So to fix this, I implemented an isolated scope, and I added all these attributes. So you basically pass in the data, which is right here, form data. So you pass in the data to the pie and what to change on, and the height and the width. So as you can see, the pie chart is reusable. We've already seen the other two pie charts. There's two more pie charts on our mortgage calculator page. Uses the same directive. The only thing that changes with these two pie charts, actually, if you notice, is just the data element. And that's one of the main motivations for using D3. D3 promises data-driven documents. So these pie charts are totally data-driven. Any data that you pass into it is going to be what's going to cause it to change. This is our first pie chart, and this is our second pie chart for my teammate Carlos Lores's mortgage comparison tool right here. Use the same D3 directive that I'm using, that I made actually. So the pie chart is reusable. It's very cool. And yeah, it's totally data driven. The pie chart acts on data given to it, and it'll change based on the data that you give it and that you specify. So that's one of the coolest things about using D3 and the custom directive. Now let's jump into the testing. So to test the pie chart, I developed 3 different tests. The first test checks the integrity of the div element that contains the pie chart. This is important because the attributes that you pass onto the pie chart along with the data have to be correctly parsed by the directive, or else the pie chart won't actually display the data information correctly, and it won't change correctly whenever there's a change in the model. Second involves checking that the SVG element exists in our HTML document. And lastly, checking each of the wedges or arcs. So D3 specifies a class for each of these wedges, which are called arcs, and they're actually called G data elements. So these are important because these are the actual wedges, or like percentage of the total monthly payment. So these also have to be parsed and created correctly. Now let's run our script.py so we can test our pie chart. And the first test, as I mentioned, is going to be checking the integrity of the div element, asserting that the div element exists and the attributes are parsed correctly. So that ran just fine. Now we're checking that the SVG is parsing the height and width correctly, and that the SVG element, of course, exists. And the most complicated test is finally checking the wedges. The wedges have to have the dimensions that are specified in the attributes, and ran 3 tests in 30 seconds. Awesome. So our pie chart is working as tested, as we wanted to. And integration. So the pie chart has not been integrated just yet into the master BreazeHome production server, but it has been merged and integrated with our local branch. This is the mortgage calculator's local branch. And here's the D3 pie chart directive. Same one that you just saw in our local app. And here's the view. So the only things missing for this pie chart or user story to be complete is to upload the documentation and video to the wiki. Documentation is already complete. And have it signed off by the product owner. And lastly, merging and integrating onto the production server. So yeah, that is basically it for the data pie chart.